So,
Hi everyone. We are just shortly sharing our screen and we should be live on all platforms really soon. Thanks for joining our webinar. Give me a second. We are just toggling on live streaming and I think then we'll be set. Pavan,
can
you're
you
able
see?
to share your screen? I'm actually not seeing anything. Like it
Okay,
says that
let
you
me.
can you try to reshare?
Yeah, I'm doing that. Oh, it is now loading. Maybe. Okay, now
Yeah, no
I'll try
worries.
to
So,
share the
for
screen.
everyone that has joined, hi, I'm Yukti. I'll be your moderator for today's session. I'm a growth engineer here at SingleStore, and Pavan will be the speaker for this webinar. So, you might notice one thing that you are currently in a listen-only mode, and there is a Zoom Q&A button that is present at the bottom of your console. So, you should be using that for asking any questions or interacting with the host. This webinar will be based on Agentic RAG. So stay tuned. I think we've lost Pavan here for a bit. So it should be all right. Like within a bit, he should be logging in. So yeah, like if you have any questions, we have a dedicated Q&A session that will be held towards the end of the session. So stay tuned for that. And like we also are today giving $600 worth of free credits if you sign up using the link that I will be posting in the chat. So there is a small button called chat. You can access that and I will be sending the resources to everything. Pavan also has a resource notebook. That's basically a GitHub link and you can use that as a resource and follow along in real time. As we have Pavan back, just give me a second to check like what's like wrong with his internet, I feel. Oh, seems like he's left us alone. Hi, Pavan, you're able to see me?
Yeah. I mean, my
You
laptop
just
is giving.
it's all right. No, it's all right. Your laptop's all right. Do you want me to share my screen?
No, I'm sharing my screen.
Cool. Okay, awesome.
Can you now see my screen?
I mean, it's saying that you've started sharing your screen, but see, I have an idea. As of now, you
Wait, I
can send
mean,
that link to me, or maybe
it
retry
is
it.
loading. Yeah, I don't know why it is kind of
Yeah, generally
loading
it
and
never
loading.
really happens.
Okay, I'll share that. Maybe I'll share the PPT with you. You can open from there.
Awesome. Yeah, you can share the PPT
It
with
is
me.
loading though. It is loading.
Okay, no,
So
no worries.
let people join also so that we can wait for.
Yeah, we actually have substantial people. You can share the presentation with me, and at least meanwhile, I can share it with the folks.
Okay, one second.
Yeah.
Not able to click anywhere. So
Oh, you can stop
stop
sharing. It's all
share.
right. Yeah.
I did that. I think I need to leave or something. Let me see.
No worries.
Why
You
it is
can
happening
leave,
today?
exit. Oh, we can see your screen now. Yeah, if you're
Now?
sharing your entire screen. Yeah, I can see your screen.
Oh, okay,
Awesome.
so it
Okay.
took so much time. But it
Oh my
is
God.
still loading.
All right. So
So now I'm able to, can you see I'm moving to different screens.
no, I'm not able to see. Actually, if you can share, like send it to me. I'll present. It's all right.
Now
Oh,
you
we
should
can
be
see a
able to.
screen. Yes, I can see it. Awesome. Okay. Thank you, Pavan.
Okay,
So,
no worries.
Pavan, like I'll just introduce Pavan for a bit. So he'll be your speaker for today, and I'll be your moderator. Sorry for the delay because like these kind of technical snacks they keep on happening. So it's called building agentic RAG applications. So stay tuned, and we'll be covering everything. This will be a hands-on session. So if you want to follow along in real time, we have the resources all set for you. I will be providing the links to everything in the chat. So stay tuned for that. Keep an eye out. Uh, we have a small GitHub link that will be like a notebook, and everything will be shared to you as well, like afterwards the session. So, yeah, Pavan in our company, he actually has been a very regular speaker at our webinars. He is a technical evangelist and a developer advocate here at SingleStore. And yeah, uh, we have more amazing sessions that are going to come up in the future. So stay tuned for that. I'll send an email. Keep an eye out. And Pavan, please take it away. Thank you so much, everyone, for your patience again while we navigated through these technical stacks. So awesome. Okay, take it away,
Okay.
Pavan. Thank you.
Thanks, Yukti. So I'm audible and screen is visible now, right? Cool. Okay. So, yeah, thanks, guys. Thanks for joining today's webinar on building agentic RAG applications. So, I started talking about RAG previously. So I wanted to upgrade myself and talk a little bit advanced topic. Then I thought agentic RAG will be a very good topic. So today's webinar is all about building agentic RAG applications. So this is the simple agenda I'm going to talk about. I'm going to talk about LLMs. I'm going to talk about techniques to improve LLMs. And I'll talk about RAG, Retrieval-Augmented Generation, and then agentic RAG. What is agentic RAG? And since we are talking about agentic RAG, we need to talk about AI agents. And I will talk about how RAG is different from agentic RAG. And then we will see agentic RAG workflow, and we will also see agentic RAG systems. And we will see the evolution of AI systems as of now, like how they started and where we are now today. And we will also talk about SingleStore, why SingleStore as the only database or an all-in-one data platform you need to use rather than using different databases at different points. And at the end, like Yukti mentioned, it's a hands-on webinar. So there is a agentic RAG tutorial I'm going to show you, and I'm going to explain you bit by bit how agentic RAG basically works. So let's get started. So my name is Pavan Belagatti, and I'm one of the top voices on LinkedIn. Uh, this followers count is little less. I increased to 1,000 more, so now it is 91K almost. So yeah, I mean, I'm one of the authors. I have written more than 100 200 articles on different technology uh, publications on different topics. So that's about me, and currently I'm working at SingleStore as a developer advocate or technology evangelist, you can call. So let's talk about large language models. What are they made up of? So as you know, they are made up of data, architecture, and some kind of training. Data can be structured, unstructured, can be anything from Wikipedia, YouTube videos, anything you find on the internet, structured, unstructured. And then comes the architecture, right? The transformer architecture is what we call, which came from Google. Google suggested this model. And then the training, it can be human involved or not involved. So data, architecture, and training, that's how the large language models are made up of. But are just LLMs enough to build the robust AI applications or chatbots? Right? Not exactly, because large language models have these kind of limitations. So what are those limitations? They, first of all, they have knowledge cutoff date. So all these LLMs have their training data cutoff date. That means, maybe like, ChatGPT cannot answer what happened, what is the temperature today in Bangalore or Mumbai. Maybe now, because most of the LLMs are now sophisticated, they can do much more. They can do tool calling and all. But that's what most of the Claude and all can't do that. They can't retrieve the real-time data. And the second thing is they all hallucinate. Sometimes they come up with their own answers, made up answers. They can't verify their responses properly. And then these things, LLMs don't have the access to the proprietary data. For example, if you are in a healthcare sector, you can't use a generic LLM model to build your chatbot application, right? That's where it fails. So since it doesn't have the proprietary data, the custom data that you have. And then there is always context limitations, context window limitations. So these are some of the limitations that large language models have. So what are the techniques then to overcome these limitations, right? So these are some of the techniques to improve LLMs. One is prompt engineering, the art and science of working with your prompts, the way you use prompt. It all depends on the prompt you use. Not a big deal. It's very easy. And then comes fine tuning. Fine tuning is where you use the base model and you basically try to add your custom data, try to train the base model with your custom data so that it starts understanding your vocabulary and it can easily adopt to your what do you call your system and where do you work, all that thing. Fine tuning is kind of bit challenging and there needs a lot of computing power and it's kind of costly. That is where RAG is the recommended technique to improve LLMs, where you use an external database and you augment all your custom data there so that the LLM can easily retrieve the required data from there without hallucinating. So that's where in all these three prominent techniques, RAG is the recommended technique to improve LLMs. So give me a So all your LLM needs an expert knowledge basically to not hallucinate and to build the chatbot or any AI application properly. So that's where RAG comes in. And as you can see here is the simple differentiation between how it is to use just LLM to build your chatbot application, how the RAG actually works. If you use LLM, the query goes in and it just goes through the LLM model and you get the response. So you can't actually verify your response there. Who knows the response is clear and how to evaluate that? That's not there. And you even don't know if the response is contextually relevant and that's the response you want. But in RAG, as you can see, there is a document. All your custom documents are present in your vector database. And when a user query comes in, it can easily go through the vector database, find the relevant chunk, and retrieve that relevant chunk. And it can actually go through the LLM model to give you the contextually relevant response back. So that's how RAG is considered more authentic and a recommended one when it comes to even improving LLMs. So that was the basic differentiation between using LLM and then RAG. So here is a complete process of retrieval augmented generation. There are three process steps basically. One is document processing, second one is query processing, and then the third one is response generation. As you know, LLMs, like we discussed, LLM usually they hallucinate. They come up with their, if you ask a question, they come up with their own answers. It can be made up answer. You never know. And since there is nothing to verify the answer, so RAG is an approach where you can enhance your LLM with the external or custom knowledge. So they don't hallucinate and generate inaccurate responses. So RAG is an approach that gives LLMs the extra context, the context about your data, right? The custom data, so that it basically doesn't hallucinate and come up with its own answers or responses. So this data can be augmented using an external database. That's what we call vector database, right? So RAG basically connects your AI applications and systems with external knowledge sources so that accurate and contextually relevant responses can be generated. So that's about RAG. As you can see, the first step is document processing. Your documents, your custom documents gets chunked. They get all these chunks get embedded so that the machine can easily understand these zeros and ones. And all these embeddings are stored in a vector store like SingleStore. That's about document processing. And when a user query comes in, the user query also gets converted into a vector embedding. And using the vector search methodology or semantic search methodology technique, it goes through the vector store to find the relevant chunk. Now that you have the relevant chunk and the augmented query, it goes through the LLM model at the end to give you a contextually relevant response, to generate basically a contextually relevant response. So that's how you get accurate response to any user query, right? That's how RAG workflow basically works. And this is a simple example I always use, like without RAG and with RAG, what type of contextually relevant responses you get. So as you can see, if the query is all about what treatment options for this patient with stage 2 NSCLC. So if you just use a pre-trained LLM in your chatbot application, the answer will be just like, since all these LLMs have the knowledge cutoff date, they are not up to date with what's happening today, yesterday. So the answer can be like, based on my training, standard options include surgery, chemotherapy, or radiation therapy, blah, blah, blah. But if you see, if you use the same query with RAG technique, with RAG approach, as you know, in RAG, we can easily augment our custom data and all the real-time data using a vector store, vector database. If you ask a same query, like what treatment options for this patient with stage 2 NSCLC, you can see a completely contextually relevant response, right? Based on 2025 NCCN guidelines and recent trial keynote 671, we consider immunotherapy with blah, blah, blah. So that's how RAG makes a lot of difference when building AI applications. So in RAG, there are different things, like we came from traditional RAG, the Naïve RAG is what we call, and then, excuse me, and then there is advanced RAG. So let's talk about Naïve RAG, right? So name tag is very simple, like we saw before. The Let me go back to, so it's like document processing, query processing, and response generation. Similar to that, you have your documents, the custom documents. They get embedded. The Using an embedding model, the embeddings are created, and all these vector embeddings are stored in a vector store. As you can see, there is a vector database. And when a user query comes in, it goes through the vector database using the similarity search method and finds the similar documents. And at the end, it goes through an LLM model. Now that it has augmented query and the context, it can easily generate the contextually relevant response back. So as simple as that. So there are no any advanced techniques used here. So how it is different from the advanced RAG? As you can see, there is pre-retrieval methods like query optimization, query retrieval techniques. And as you can see, there is also post-retrieval. You can use hybrid search, re-ranking. You might get, for a same query, you might get 10 different types of answers. So how will the system know that which one should be up? So that's where you do re-ranking methodology, so that you know the score. You will get a score for one, like 0.91, 0.92. So depending on that, you can actually see that, yeah, this is the most relevant answer for this user query. So that's how the pre-retrieval and post-retrieval techniques used in the RAG, advanced RAG. So here is a simple, again, example of the differences between naive RAG and advanced RAG. The user query is like, as you can see here in the naive RAG, right? The user query is like, what is RAG? The query gets embedded. It goes through the vector search. It goes through the vector database using vector search methodology, and then you get the chunks, the related chunks, and now you have the context and query, and it goes through LLM model to find to give you the contextually relevant response back. But as you can see in the advanced RAG, there are a lot of advanced techniques that are used, right? As you can see, for the same question, what is RAG? The query enhancement usually happens like query expansion, query decomposition, multi-perspective of the query happens, and then the multi-stage retrieval happens using, like I said, hybrid search, re-ranking, filtering. It can be like keyword search, like full text search. That's where hybrid search comes in. So, and then you use some advanced knowledge base. It can be multi-model vectors, hierarchical chunks, metadata enriched, graph connections, right? And then it goes through the context processing using different techniques, as you can see there. And then advanced prompting, like chain of thought, few short examples, role specification, output formatting, and then at the end you can also see the generation and validation. So you will basically get a very high quality output using advanced RAG because of all the techniques that you use in the pre-retrieval and post-retrieval phases. So then what the heck is agentic RAG? We saw naive RAG, we saw advanced RAG. What is agentic RAG? So now we see AI agents are all the buzz because of all the autonomous things that they can do, right? So agentic RAG is nothing but RAG plus AI agents, right? That's what agentic RAG is all about. So AI agents, what are AI agents? So AI agents are the systems that they can perceive easily, they can reason, and they can act independently. So they can easily. So if a user query comes in, these AI agents, these agentic systems have the capability to decompose that complex user query into multiple chunks, and they can basically split the whole complex task into multiple tasks, and they can easily assign each task to each agent, and there can be again one agent or there can be multiple agents. That's where we call multi-AI agentic systems. So agentic systems are basically, they can easily perceive what's happening, what is the prompt is all about, what the user is asking, and which tool I need to use. So they basically take independently their own actions depending on the query and depending on the type of the prompt asked. So that's where AI agents are more sophisticated, and most of the companies they want to use AI agents and build agentic applications. So this is a simple AI agent architecture, which is much better than just I'm saying like perceive, reason, and act. So there is a memory component that can have short-term or long-term memory. And as you can see in the center, there is a task plus role. This agent will have its own task and role assigned to it, and it can plan, it can reflect on itself, and it can actually do basic tool calling. Like if I ask like what is the weather in Bangalore today, so it can basically go do if there is a weather API, it can call that. It can, if I ask what is the recent news uh, about sports in Mumbai, I can easily go to any sports website and do the web search. That's where we call tool calling, and then it can actually get all the news and share it to you. So it can basically plan and do the tool calling. Tool calling, the function calling is what we call, and it can actually have the memory also. To if you ask the next question, it can have like the short term or long term memory to make sure that what happened before, and it can easily relate and answer back to the next questions. So that's how a simple AI agent architecture looks. And for example, if you ask like, hey, find me the cheapest flight to Singapore. So the agentic applications, the agent can actually tell you that, hey, I have to look for 10 more websites. Let me compare those websites. Maybe there might be API calling or tool calling I need to do. And then let me go to these 10 websites that suggest the flights to Singapore, and then maybe make my trip, and there can be clear trip and all those things. And let me compare and give it back to you. So that's how AI agents are more useful these days, that they are more autonomous and they take their own actions, right? So this is how RAG versus agentic RAG basically compares. Like we saw traditional RAG, which is nothing but Naïve RAG. The user query comes in, it gets embedded, and using a vector search, using the vector search methodology, it goes to the knowledge base, that is our vector database, finds the top relevant chunk, and then it goes through the LLM model to generate the final response. Whereas agentic RAG, it can actually plan itself. First, the query analysis happens, and then it will see like, what should I do? Uh, should I do tool calling, or should I just go with if the answer is already present in the vector database? Should I go there? So it basically does reasoning, planning, and it can be multi-step sometimes. So it can do this iterative retrieval until it gets the final answer, right? If it reflects itself. So that's where it can actually be more autonomous, and it can easily get the contextually relevant, not just contextually relevant, but amazingly well high quality response back compared to just a traditional RAG, right? So this is a simple again RAG versus agentic RAG. the feature comparison, like focus. If you take focus as a feature, traditional RAG, as you can see, it's more isolated retrieval, and it's usually used for generation tasks. And like agentic RAG is more of a multi-agent collaboration and reasoning. And context maintenance in traditional RAG, it is very limited, whereas in agentic RAG, it is enabled through memory modules like short-term, long-term memory, and all those. And dynamic adaptability, it's very minimal in traditional RAG, whereas it is very high in agentic RAG. And workflow orchestration is not at all present in the traditional RAG, since it's a very easy, simple, linear flow. Whereas in agentic RAG, it is very much possible. The the workflow orchestration, right? And since there is a multi-agent tasks also can be possible, and use of external tools on the APIs, very basic integration can be possible in traditional RAG, whereas in agentic RAG, as you can see, you can extend via tools like APIs and knowledge base and whatnot, right? You can have multiple data sources connected. And when it comes to scalability, when it comes to for traditional RAG, it is very limited to small data sets or queries, and whereas for agentic RAG, it is scalable for multi-agent systems. You can use single agent or multi-agent. We will also see what is single agent and multi-agent in the next slides. And when it comes to complex reasoning, traditional RAG, since it is very linear, very simple, it's kind of very basic. And whereas agentic RAG, it's multi-step reasoning with agents. It can iterate itself to self-reflection. So complex reasoning is possible in agentic RAG. And the primary applications is like QA systems and traditional RAG, like knowledge retrieval. It's only pertaining to that. Whereas in agentic RAG, it is much more of multi-domain and reasoning and all those things. So here is again a simple workflow of agentic RAG workflow. As you can see, there is a central system that is AI agent application. We can actually do tool calling, the function calling, and there is a standard RAG retrieval where the persistent knowledge can be present in a graph database, like vector. There can be vector database, and there can be relational database like single store, and there is also LLM layer, which is also present to help you with different LLMs that you can use. So using all these things, the agentic RAG workflow is much enhanced and used to build highly relevant workflows. So like I was saying, so agentic RAG systems, there can be single agent agentic RAG, and there can be multi-agent agentic RAG, right? So as simple as that, single agent agentic RAG functions as a centralized decision-making system where very single, only one single agent is manages everything, right? Starting from query evaluation, knowledge source selection, data integration, and response generation. So in contrast, multi-agent agentic RAG, as you can see, there are different agents present, right? Agent X, agent Y, agent Z, that are connected to different sources. So like I said, right, multi-agent agentic RAG systems distribute retrieval and reasoning tasks across multiple specialized agents, making them modular, scalable, and capable of handling complex workflows. So if the workflows are simple, you want to build simple workflows, a single agent agentic RAG works really well. And if you have complex workflows where you're doing multiple things, then multi-agent agentic RAG works really well. So we saw how we came from simple Naïve RAG to agentic RAG to, sorry, advanced RAG to agentic RAG. So as you can see here, how we have evolved our evolution of AI systems, starting from standard LLM applications where we just saw where when we saw initially ChatGPT coming up, like basic text generation, completion systems with singleton interactions with fixed prompts, right? And then we saw enhanced applications with amazing context window, like multi-tone conversations with improved context understanding and better instruction following on all those things. And then we saw tool calling systems where LLMs can easily call the tools and APIs whenever it was required. It was all amazing. And then we saw early agentic AI applications in 2023-24 the first autonomous AI systems with self-directed goal pursuit and task planning capabilities. And then now what we see is much advanced multi-agent systems where more than one AI agent come together. They collaborate together to form, to complete a complex task, right? So that's where we see um, the AI systems are evolving towards. And yeah, I mean, let's talk about a typical enterprise data architecture, right? So as you can see here, um, uh, so in your company, your customers might be initially running some analytical workloads, right? That's what we call OLAP. And then you feel like having a OLAP database since you're supporting your customers. And then after a certain point, some other demand comes from your sales team or some marketing team, and some customer will ask you for the good customers will ask you for the transaction since they are running a lot of transactional workloads. You feel like having an OLTP database, right? And then now all the hype is about generative AI applications, and you feel like having a data vector database. So as you can see, all these databases create a lot of complexity in your whole data architecture, and it can be really very challenging for your data architect or any DevOps guy or any developer that in your company to handle all these different databases at different stages. So what we say is like, use SingleStore as an all-in-one data platform so that you don't have to use specialized vector database or any PostgreSQL or Elasticsearch or any other database, because SingleStore will help you with ingest and index documents, re-ranking, hybrid search, filtering, similarity matching, and SingleStore supports all types of data, and you can easily build any type of robust AI and RAG applications and much more you can. So that's what we call like, using just use SingleStore as your all-in-one database instead of using different databases. So we have come to the Agentic RAG tutorial here. So this is the Agentic RAG workflow that I have created. The user question like, what's new in AI this week? If the user query is like, what's new in AI this week? The agent evaluates the query and it makes the decision, hey, should I use a tool? And if I have to use the tool, should I use which tool? Like there is a Wikipedia knowledge base and there is a live web search tool. Should I go to Wikipedia knowledge base or should I go to live web search? So in this case, it will actually go to live web search since it's about the AI news. So let's see how this actually works. Okay. For this, you need to have the single store account, and I can also share you the. Um, let me chat. So I just shared the link there. You can go to that link. Oh, Stan Palace. Okay. Yeah. You can go to that link, and there is also this GitHub tutorial, GitHub repo that you can just go through. I'm gonna explain it step by step. So using this link, you can sign up, and once you sign up and sign in, this is where you will land. So first things first, you need to have a workspace ready. So I already have a workspace, and attached to your workspace, have a create a database. So I have my database already created. I think it's called Agentic something. Let me see. Yeah, I have already created this database attached to my workspace. Okay, so now let's go to the notebook. So once you created your workspace and database, and okay, so you can go to query editor after that, and then create a new notebook. So create a new notebook, make it shared or personal, give it a name, and then just create. So once you create that, this is where you will land. So yeah, here is my complete notebook code. Agentic RAG with Wikipedia plus Tavily plus SingleStore. So Wikipedia, we are using Wikipedia. We are getting all the content from there. We are embedding all the data. And then we are also using Tavily Search. It's a search API. And then we are also using SingleStore as a vector database to store all our vector embeddings. So what we're creating a smart AI system that can answer questions using both a private knowledge base and live web search. So all powered by LangChain. LangChain is an open source LLM framework to help you build LLM powered applications. And OpenAI is what we are using. Tavily we are using Tavily Search and SingleStore to store our vector embeddings. So what makes our system agentic, right? So it can basically autonomously decide when to use internal knowledge or when to use the external knowledge base. Go search the web and using multiple tools intelligently, not just one hard-coded path. So we are basically the system is flexible. It decides itself depending on the user query. Should I use the already present internal knowledge base or should I go search the web? And it has the memory that makes it making it contextual over multiple queries. So basically, it can think, it can choose, and it can actually act. So this is a complete workflow. Like I said, right? What is new in the user asks a question like, "What's new in this in EI this week?" The agent basically evaluates: should I use my Wikipedia knowledge base or should I go to search live web and search for the answer? And agent calls the best tool at that time or does the API calling or tool calling and then returns the contextually relevant response back. So let's see this in action. So before everything else, make sure that you select your workspace that you created and the database that you created. This is my workspace, PowerPX workspace one, and Agentic is my database. So I selected that, and let's go to the first step, that is install the required packages. So like I said, we are using LangChain, SingleStore, Wikipedia API, and we are using Tavily. Okay. And then we'll set up imports. We are importing all the required um, things. And then we'll set up environment variables. You need to add your OpenAI API key and Tavily API key. Go to tavily.com. I think it is Tavily. Yeah. Uh, and then get your open API key from Tavily and then add it here. And you need to get SingleStore host, port, user, password, and database. So how can you get that? So go to your deployments. There is a connect button. Go to SQL ID, and this is where you can find your host, port, username, and then password can be found, can be, you can get it from here actually. Do reset and you will get it from there and add everything, run it. So that's what we are doing, setting up the environment variables. And next we'll set up the single store account, like single store setup. So let's establish a connection to your single store vector database to store the retrieved and retrieve embeddings. So that's what we are doing here, right? We mentioned our host, port, username, password, and database name, and we got connected to our single store. And then we need to create a table to store our vector embeddings. So that's what we are doing here. We are creating a table named Wikipedia Wikipedia vectors. So we created a table. Now we will do Wikipedia content fetcher using the Wikipedia API. That's what we are doing, and we're using these topics to get the contents from these retrieval-augmented generation, machine learning, natural language processing, deep learning, computer vision, database. So these are the 5 topics that we're using, and we're getting it from Wikipedia, as you can see, right? We're fetching it from Wikipedia. So everything is getting fetched. Fetched 6 pages successfully from Wikipedia using the Wikipedia API. And then we need to, now we got all the content, we need to chunk and embed that, right? And store it in our vector store. So that's what we are doing here, a chunk and embed. And then we will store that in our single store database. As you can see, single store stored 409 vectors. We stored all our vector embeddings in our vector store. Now let's build a retriever, like create a custom retriever that queries the vector database using cosine similarity, right? That's what we are doing here. And we are basically using cosine similarity to find the relevant chunks from any user query when a user query comes in. And then now this is the main part, defining the tools and agents, right? We are defining our tools, the Wikipedia agent, and then the answer with context and Tavily Search. These are the tools that we are using, right? And we are basically initializing that with LangChain agent. As you can see, the class is Wikipedia RAG agent, search knowledge base, answer with context, and then the tool name is Wikipedia knowledge, answer with context, and then there is a Tavily search that we are using, and then we are using some parameters here. And then let's test this all after we do this defining tools and agents and what each agent does. So let's test it using these questions like what is retrieval augmented generation? What's new in AI from the last 24 hours? Compare ML and NLP. What is Gen AI being used? Where is Gen AI being used in business? So we will run this all at once. So as you can see, entering new agent executor chain. So it is uh, entering the chain, and the first thing is thought. So it's asking like, do I need to use a tool? Yes. If that, what is the tool I need to use? Answer with context is the tool we need to use. The action input is retrieval augmented generation because that's the question we have asked. What is retrieval augmented generation? And then it goes through the observation thing and it gets the answer, and again goes through the thought, and since it gets the final answer, it will finish the chain. Do I, again it will ask like, do I need to use the tool now? No, because we already received the answer. So the AI will answer back, AI system will answer back saying retrieval augmented generation is a technique that enhances LLMs, blah blah blah. The same you can see, and it will also say finished chain. And then it enters the next query, that is, what's new in AI from the last 24 hours? And it will ask again, do I need to use a tool? Yes. If that's the case, what tool? Like, what is the action? You need to use Tavily search results because you need to get it from the web since it is not present in our knowledge base. So the action is what's new in AI from the last 24 hours. So it will go through all those websites to get the recent news about AI. So again, it will go through the thought mode and it'll ask, like, do I need to use a tool? No, because we already got the answer. And here are some of the latest AI breakthroughs and news from the last 24 hours. So it goes through iteratively, it goes through until it finds the proper relevant answer. And it will finish the chain by giving you the proper answer. As you can see, scientists are using AI to predict brain age from MRI scans, blah, blah, blah. NVIDIA and Foxconn are in discussion to deploy humanoid robots, blah, blah, blah. Again, it will go through it'll end the chain and it enters the new agent executor chain to basically execute the next question, that is compare ML and NLP. So again, it will ask, hey, do I need to use a tool? Yes, and answer with context. It's already present because we are storing that knowledge in our database. So it goes through iteratively and it basically finds the proper answer. So that's how you can basically build. This is a very simple example, agentic RAG example I have shown here using Wikipedia, Tavily Search, and SingleStore. And yeah, I mean, I have already shared I think the repo. I think you can go through this, and if you have any questions, you can ping me. And I think, yeah, that's it. Yeah, I mean, again, how SingleStore basically works, right? Works for AI applications. So we have a complete solution, like a proper page to let you know that we are the only database, all-in-one database. Like I said, you can connect your framework, whether it is, we have a good integration with LangChain, Llama Index, you name it, we have it all the integrations. And if you're using already MongoDB, you can also use, since MongoDB is not that good with real-time analytics, we have the API that you can use, right? We have SingleStore Kai you can use, and we have the notebook thing that I just showed you, right? Where you can run embedding models, you can build different AI and RAG applications, And SingleStore also supports different types of data vectors, right? So SingleStore basically started supporting vectors long back in 2017 itself, and we support like geospatial, key value, JSON, and documents, and rows and columnar data, and all those data. And yeah, I mean, there are already big companies using um, our platform to build their AI and RAG applications, as you can see here. Some of them to name Siemens, Naïve, directly apply Lumana, and you can basically go to this particular link and see yourself how different use cases, right? How people are using, how different companies are using SingleStore. Thanks, guys. Thanks a lot. I mean, if you have any questions, I'm happy to answer.
Hi, Pavan. So thanks for doing the presentation. And now we are officially open for any Q&A that you guys any questions that you guys might have. So we have a question
Yeah, I can see
from
the
Brian.
open question.
Yeah, okay, awesome, awesome. Okay, so if you can
Yeah,
access it yourself,
can
you can
you?
also
Yeah,
take it up.
sure.
Okay.
Can you
Uh,
can
for
you
other
set up?
folks that are just give me a second, Pawan. Sorry.
Yeah,
For other folks that are they have joined late, the links to everything they're there in the chat. The recordings will be sent to you. So if you still haven't caught up with anything, feel free to ask away, and we will. Pawan is live, and we'll try our best to answer the questions. So yeah, Pawan, please take it away. Thank you.
sure, sure. So someone asked like, can you set up agents that get triggered based on specific events and not asked to call them manually? So here also we are not calling them manually. So it all depends on the user query and the type of tools or API calling. It is all done, and that's where we are going towards something called MCP, Model Context Protocol, if you know. So that's where more agentic thing we are going towards. So we are actually not doing anything manually, but to show this demo, you need to establish certain things manually to make sure how agentic systems basically work. But yeah, I mean, again, if you can have more tools or APIs connected to your enterprise applications so that you don't call them manually. So it all happens basically automatically. So that's why it is called agentic. So how does the agent determine the best tool? What defines best for? So best tool, how it defines, it goes through iteratively. So the one thing about self-reflection is one of the features of agentic applications or agentic workflows. So if it finds a tool, if it doesn't find the final answer, it again does it through a different tool. So that's how it gets to know that's the best tool. So that's the answer as of now. So what insurances do we have if or when things go when using RAG? Marfina? I'm not quite like what insurances do we have if or when things go. So that's why you are not using RAG now. RAG is little outdated. That's why we are using. Then came advanced RAG. We saw re-ranking, query optimization. Then we saw like, okay, that's also not that good. It's kind of outdated. Let's use agentic RAG. So that's where you're using multiple agents to do all these things. So I don't think now you just people are using just RAG now. They are basically using advanced agentic RAG or multi-agent RAG systems to do all the things. Will I get credits once I create account? Yes, once you create account on SingleStore, SingleStore has a free shared tier. So internally you get credits. So you can basically build what I showed in the demo or tutorial. You can build all that. Similar to this, you can build many until you finish off your credits. Do we have a vectors in SingleStore? What do you mean? Do we have vectors? So one more thing, like I want to show you how the vector, like how the data has been stored in. We stored our data, right, from Wikipedia. So let's see how it is stored. I want to show you. The database name was Agentic. So you see, this is Wikipedia vectors, sample data. So uh, we created this Wikipedia vectors as the table, if you remember. And if you go to sample data, you can see how all the Wikipedia data has been created, like in the form of vectors, vector embeddings. This is the vector embedding format. See, we mentioned retrieval augmented generation, machine learning, natural language processing, deep learning, so the database machine learning. So we basically mentioned 5 topics. So all that data got fetched from Wikipedia API and then it got converted into uh, vector embeddings, and that's how it is stored in vector store, like SingleStore. And what is the role of SingleStore here? Yeah, SingleStore, we are using it as a vector store, like vector database. So um, I signed up with a new email and still same issue. What's happening exactly? New email? You should get it. Like there is, can you email? Um, I signed up with a new email and still same issue. What is the issue you are facing? Maybe you can email or ping Yukti.
Actually, this person is not able to get some credits. Like there's, but what I'm
It's
thinking
a
is
free
that they're
share
having
here.
a, yeah, they're not having exactly, like they don't understand like how exactly the credits are credited. So if you can like, let us know about that, because from my knowledge, they automatically get credited into your account and they last for pretty long. Like mine lasted for more than a year. So,
Yeah,
yeah, like I said, it's pretty like straightforward. So, but
yeah,
still,
very
Pavan, if you can
straightforward.
explain, that would be
Yeah,
great.
sure, sure. Let me log out.
Mm.
Easy, go to single store and then you sign up. It goes through the process. Let me go to, I use, so this is my other account that I use and I'm already signed in, so I don't have other Gmail to sign in. So it's kind of very easy. Like if you have new Gmail, I mean, I don't have now, I have only 3. So go to maybe I think we'll do one more webinar on how to create a single store
Oh
account for
yeah,
the
actually, the getting started webinar is going to happen on 7th. So
okay,
we have Spandana from the product team doing that one. So that would
okay,
actually walk you through from like from literally signing up to loading in your data, accessing the notebooks.
got it.
So that's for sure. And that would be a weekly session for everyone that's joining. So yeah, that's for sure.
Yeah. So
Ankita,
please,
I see like that's not 600 credits. That is $600 worth of credits that we are talking about here. So that translates to around 28 credits. So that's the amount of credits that much of money will buy you. So yeah, that's what like that's the reiteration here, literally.
yeah. So how
So,
so how single store is different? Yeah, you have anything, Yukti?
yeah, no, please go ahead.
Okay. So somebody asked how single store is different than others like Files, etc. DB, Files, Pinecone. So uh, these are just vector databases. They just do vector search, similarity search, and all that. But single store, most of the big enterprises, the Bank of America, all those guys use us for real-time analytics on top of just building AI applications. So, like I said in one of the slides, you can remove like Pinecone, Quadrant, and all these guys, Milvus, they just do vector, they're just there as a vector database. Since all the hype, because of the hype of Gen AI and all those things. But single stores, like I said, single store started supporting vector storage long back in 2017 itself. So single store does much more than what just the vector databases do. They might be doing quite well in only like vector search, hybrid search, but what if on top of your AI applications, you want to do real-time analytics? So that's where we come in. Like, so that time you don't have to search for another database. You can use SingleStore to do all your things at once. Is the memory management being done by LangChain in your example? Yes, I'm using LangChain to combine everything, and yeah, that's how I'm managing the memory. What other role will LangChain play in example? To binding everything together. So that's where I'm using LangChain to build the agentic workflow. Right? You can use LangGraph also, and you can use like QAI and all those things also. But here, since we have a good integration with LangChain, so that's why I'm using LangChain here. Yeah, Ankita Yadav. Yeah, I think we have one more session coming up on how to install SingleStore. We have a Docker image also to install SingleStore. That will be very easy if you have Docker installed on your computer desktop. It's very easy. It's you can just run that Docker image and you will be up and running on your local very easily. So you can search for SingleStore Docker and then you will get it, I think. Yeah, you can refer this. Yeah, yeah, I think we have one more webinar coming up, and that way you will get to know a lot of things. Maybe you should go here, maybe try this and see, go to this single store dev image repo and we run it from here. If you're running in Docker, is there still a cost? No, I mean like you can just try it. Like it's for experimentation. You can just read this out and try it yourself. Since you're running it on your local, I don't think you will get any. You don't have to pay. So in your example, how do I add another tool to the mix without using MCP, so etc. Okay, I have not extended it because that's what I was looking for. Very simple. Maybe I think you can extend it, add one more tool. Yeah, maybe in the next webinar I might do like multi-agent RAG workflow, how to build multi-agent RAG workflow, something like that. That's where I can build do lot of tool calling and show you. Yeah. Thanks, guys. If you have anything, you can also ping me on LinkedIn, and I'm very active on LinkedIn also. Connect with me on LinkedIn. But thanks for today's attending today's session, and yep, go sign up to SingleStore and get your uh, free credits. Thanks.
Awesome. So thanks everyone for joining, and thank you so much, Pavan, for doing this session with us. Guys, we will
Thanks.
be back with another webinar session really, really soon. So stay tuned for that. We have more upcoming events. We have a webinar on Single Store's MCP server that's going to happen a month from now. I know it's a bit late, but yeah. So we have a personalized MCP server which can be run through Single Store. So that's really interesting. We have the software engineer that like literally built that from the scratch, do that session. So it's going to be super insightful. I will be sending an email to everyone with the recording. So thanks for being such a patient audience. Like we had so much of issues with the screen. So thanks everyone for hanging on. And you can always email us or reach out to us on LinkedIn. Me and Pavan are very active there. So if you have any questions, feedback, if you want to share any projects that you guys are working on, and you might want to see that during our sessions for our webinars, so please feel free to connect with us. And yeah, So if you have any other questions, yeah, our DMs are open, and have a great rest of the day. And thanks for your time and attending this webinar. Pavan, if you have anything else, let me know.
Nothing. Thanks, guys. Thanks for
Okay.
joining. Bye.
All right. Thanks, everyone. Bye.